Hey there, everyone. My name is Ryan Schul. Welcome to my channel. I just recently, just literally today, I rebranded this from straight data science, which basically means straight truth. And the topic was data science. I've rebranded this into analytics um, in practice. That's the name now, analytics in practice, because I think this is much bigger than just data science. This is all of analytics, right? So if you look at some of the history of videos I put up here, a lot of it is focused on data science, but I felt like there's a considerable amount of content that was not really related to data science or had nothing to do with data science whatsoever. And I'm coming out with a lot more videos soon that really have nothing to do with what is defined as data science. So I'm rebranding as analytics in practice because it's still going to be very analytical, but I'm solving practical problems like I have always been doing, but not just focused on data science. So in today's narrative, I want to talk about hierarchical time series forecasting and what is it and what can we do with it and how can this help us, right? So there's three big reasons why we would try to do this type of analysis, hierarchical time series. So coherence, you can't just do forecasting, okay? That's just going to be nonsense, and ultimately it's not going to tie back to what actually happened. If you forecast something, you could say, okay, maybe next year or in the next 6 months or whatever, we will make $1 million. And in that same time, or as time goes on, right, you look at the actual numbers you're actually generating, it could be 1.2 million. So you could beat your forecast, right? But these are never going to really reconcile and tie back to each other. So you kind of have to look at two different perspectives, like a top down, and you look at the big picture, and you go down to the little, or bottom up, you look at the small stuff and sum everything up into the aggregate amount at the top, and then reconcile these two, okay? So we're going to have a couple different perspectives here to gain coherence. We want accuracy and we want improvements in the current methodology, okay? So there could be some noise, there could be some choppiness. That's okay, that's to be expected, but we want to ultimately try to eliminate that as much as possible and have nice, smooth forecasts and sales, summing and aggregation, right? And ultimately everything has to tie back together, right? And finance people really like that, right? If everything is in a state of disarray and chaos, people are going to hate that, right? I worked on Wall Street for more than 20 years. I did a ton of reconciliation, and a lot of times these accounts don't reconcile at all, right? The whole job was to tie everything together, and if you lose $10 million, and they would lose millions and millions all the time. They called it rounding errors, right? You could just lose 10 million. I don't know where it went. It went to some other account where it's just missing. It's MIA, right? So finance people deal with this all the time. It's very annoying. People create careers out of this, right? But you have to ultimately find that 10 million. If that's missing, that's okay. That's rounding error, but you got to go fetch. You got to go get that and get that back and account for that, right? So it has to be certain accountability. We want natural rollups. We want to have very smooth reporting, and we don't want this choppiness and all this noise. We want to try to eliminate it, but also it's inevitable too, right? That's what people spend their entire careers doing, to try to tame these beasts, and it's hard. I've been in the trenches doing this for years. It's hard, but you can get your arms around it. That is doable, right? So we're going to look at a few different things here. In this case, I want to look at a hotel chain, okay, operating in different parts of the United States. We are going to do forecasting and total bookings, and this is going to be big picture for our investors or key stakeholders, but also forecasting is need for staffing, right? So we need the day-to-day staff at the hotel, and we need to do reporting for our investors, right? Maybe some investor pumped 100 million into this hotel chain or whatever. We need to be able to do accurate forecasting for these people as well, right? Forecasting even for room type based on seasonality and the pricing of these rooms. I've got a couple of videos on my channel about hotel room pricing. What's the optimal price? The dynamics of pricing, right? The pricing can change throughout the year. We'll see examples of that. And of course, based on the city that you operate in, okay? So let's go ahead and jump into it. I'm going to hit Control Enter to run the code in this cell, and we're going to create a dictionary with some data from New York City, Miami, Nashville, Denver, Los Angeles, Portland, Oregon, and Seattle. So we're covering a big chunk of the country here, different time zones, different operating budgets in these cities, different needs, different demands, right? And different peak months too. So I'm setting some peak months over here, number of rooms, and are there going to be some events available so the hotel can also generate some revenue from different events. It could be anything from a wedding up to a holiday party, right? So we're going to account for revenue from those streams as well. Okay, so we're starting on this date. These are all changeable too, by the way, right? So you can set this to be anything you want. We are going to look into the future 48 months. So that's 4 years. Again, this is all changeable, all fungible. You can do whatever you want with this. I'm just trying to come up with a couple different scenarios. A base case scenario, which is most likely bullish, which is going to be a little bit more aggressive. We're going to have more business than the base case, and a little bit bearish too, because the frequency with which these rooms are rented out could dip. It's not always going to be average. It's not always going to be bullish. It could be bearish as well, right? So we have a few different scenarios here, and we have different seasonal patterns, right? So we have winter, summer. We have different geographical regions. This is mountain. This is the coastal region, and some of these cities could have holidays or festivals occurring in the city, right? So we're looking at all these different scenarios. And by the way, I have to create this data synthetically because I don't have actual data for Hilton or Marriott or any of these big hotel chains, right? I'm trying to show you, if you work for these institutions or even a restaurant, guys, even if you work for a restaurant, you can take that data and plug it into these models. I'm going to show you in just a minute, and do your forecasting for that, your hierarchical time series forecasting for a restaurant, for a hotel chain. It could be for a cruise line, right? It doesn't matter. We can make up all these assumptions. I don't work for a cruise line. I don't work for a hotel. I don't work for a restaurant. I'm not even working. I've been out of work for 18 months. I sent off thousands of resumes and got rejected from all of these things, which to me is bizarre, but that's the reality too. This is a very weird period that we're in. This period in time right now, what's the date? September 23rd, 2025. That is weird. I've interviewed for jobs that I'm completely qualified for. I could go in day one and be up to speed before 5 p.m. the first day, right? But people are saying, no, you don't have the right experience, and we know you went through close to a dozen interviews, but we're not ready to pull the trigger on this, or we're not confident or whatever. I had an interview with 2 kids a couple days ago. They looked to me like they were 25 and 26, and they said, I don't have enough experience. I said, guys, I've got 23 years on Wall Street. You have what, like a couple? College puked you out 1 or 2 years ago, and you don't think I have enough experience? So that is bizarre, guys. You can say whatever you want to say, right? It's called freedom of speech, protected by the First Amendment of the Constitution of the United States. But just because you say something doesn't make that thing true, right? Like, truth is truth, and saying stuff is just stuff. It's just words. That's all it is, guys. So hopefully this country can get itself straightened out and we can get back on business, but who knows? Who knows? I don't know. So anyway, so I have the data. I'm going to put this into a data frame. So we have the city data scenario, number of months, the room availability, the occupancy, bookings, ADR, revenue, rooms per revenue per room, F&B. This is food and beverage revenue, event revenue. Like again, they said could be a wedding, it could be a holiday party, whatever it is, right? Could be a corporate shareholder meeting or whatever board meeting goes to the hotel, and then total revenue. Okay, so I just ran this. I'm pretty certain I'll run it again just to make sure. So we have all the variables here. Okay, that's what I just described, and we have the total revenue broken down by city over here. So I think we're in a good spot right now. So at this point, I want to go ahead and look at some basic visuals just to see what this data looks like. So Control-Enter to run the code in the cell. I like these Plotly charts. Look online for Plotly. If you don't understand how it works, totally fine. I got into this a few years ago. It was a huge learning curve for me at the beginning. I knew literally nothing, like a goose egg, nothing. I majored in finance in grad school, right? I got my MBA in finance. So I come to Python. I know nothing. I didn't learn this. I didn't take a single class ever. I just read a whole bunch of books and went online and started Googling these things and came up with a bunch of ideas over time, right? So if you don't know it, don't worry about it. You can learn all this stuff. I learned it from nothing. So here's my first plot. Okay, I like these plotly charts. You can click in and click out, and these lines will appear or disappear. This is Portland down here, Seattle, Miami, Nashville, so on and so forth. You can read, right? Total revenue of the synthetic data. Again, I don't have this hotel chain data. I don't work for, what is it called, Marriott or Hilton or any of these chains, right? So I just had to make up the data, but I think it's pretty realistic based on the cost, average cost of rentals um, in each of these cities, right? So New York tends to be more expensive. Portland tends to be a little bit cheaper. So I think this makes sense. The occupancy is about 5 to 50 to 60%. Most of the time it fluctuates a little bit. And we can see the ADRs over here. So so this gives us a good visual over the last 48 months. Remember, we started in January 2021 and finished around the end of the end of 2024, right? And all that came from is over here. These are the details for the hotel. This is the start date, and we're going 48 months into the future. Okay, so that's where it comes from. So this is good. Now we have a heat map. The average revenue by room over here. So we have Denver 125, 120, 121. Nashville's a little bit cheaper, 133. New York City, I can vouch for that. That is pretty realistic. Portland and Seattle. And you can see the change by the month. So New York is pretty consistent, definitely the most expensive. Kind of spikes up a little bit around Christmas time. That makes sense to me. And here is a little bit, maybe some spring break activity. Miami, you see a little bit spring break activity over here. In the hotter months, kind of slows down a little bit. So I think this heat map is pretty accurate in terms of the revenue per room. And here, here we can see the KPIs by city, right? By bookings, and then the total revenue for that location, right? So I think we're in a good spot. So average daily rate, right? This is what we're getting. Average per room and revenue per available room, right? So not all these rooms are going to be booked all the time. You're never going to get 100% occupancy, right? But you should have at least like 50 to 60% occupancy, and maybe it could spike up a little bit at some points too. So we see the 50%, 50 to 60% over here, and this is the average daily rate over here, right? So that pretty much makes sense. 200 per available room on average, and the revenue per available room, blended price with the average daily rate, summing this into one combine this into one metric, making it a gold standard for comparing hotel performance, right? So you really have to look at apples and apples, right? And make this apples to apples comparison. You can't look at rooms in Portland and rooms in New York City and make this apples to apples comparison. It's just not going to work, right? And you're going to be frustrated and confused too. But if you get the ADR and and the revenue PAR, this is the per available room, and use that as kind of like as a baseline metric, then you can make these types of comparisons, right? So basically, ADR is how much do we charge for the rooms that we're renting, and the revenue per available room is how much do we earn across all rooms, including empty ones too, okay? So there's a cleaning cost too. If you rent out the room, obviously you're making money for that. If you're not renting the room, in many cases, that's okay. There's no cleanup cost. You don't have to have the cleaning person come around, and you save on that expense right there. Okay, so we're doing good here. So we have the cities, the months, the room caps. Like this would be the maximum that we could get for a room, and then the base amount for the room as well. So I'm going to go ahead and create a small list here. My list is called rows. Let me see, Control F. Okay, and everything gets appended into these rows based on these bookings. The cap, this is the maximum we can charge for the room, and then the base, this would be the minimum. Okay, so Control Enter to run the cell. We can see here based on the city, pretty much the ADR average daily rate is going to be highest in New York. That goes across the board, right? The lowest would be probably Portland. If I get the tail of this, let me see what this looks like. Actually Seattle. Okay, so the bookings here are higher in New York, lower in Seattle, and these are the average number of rooms. This doesn't really change, right? It's the same hotel. But what does change is over the course of time, we have average daily rate and the occupancy right here is pretty close to 50%. So it's called utilization. I think that's good utilization. These are the dates, the monthly dates. Everything is rolled up to monthly. This is the average and the number of bookings, right? So, okay, we're in a good spot. So moving on now, we're going to create a plotly chart, another plotly chart. I like these a lot because they're very dynamic, interactive. You can see, put the mouse over it, and the numbers pop up here. And if you need to, you can zoom in and see the details here, okay? So I like to use these plotly charts whenever possible. So in this case, we have the revenue, total earnings here, the city name, the occupancy, the city we're operating, and so on and so forth. Let me expand this a little bit. Click on this. Okay, so you can see the city, the dates, again, occupancy, ADR, bookings, rooms, revenue per average room, and then the month and the year, right? So everything is summarized nicely here. This is just the head of the data frame that we're showing. So that comes from, where is it over here? Oh yeah, so that comes from right here. Okay, we're just displaying the head of the data frame. By default, it's 5 rows. We start with 0, go up to 5. It's actually 4 because it's a 0 based. So 0 through 4. And then we have all the demands for all the cities and the average daily rate. Again, you can zoom in if you want to see all the details on these charts. I like these plotly charts a lot. Double click to zoom out. So this is a nice high level visual, right? I told you before this is going to be top down and bottom up. So these are nice high level visuals for the ADRs. And the occupancy, right? So you can see it goes from about 40% up to 60%, and you have the city and the ADR. Lighter yellows are more expensive or higher. ADRs have higher average daily rates, and the purples and the dark blues are lower. So you can see pretty much Nashville, Portland, cheaper to stay in these hotels. Miami, Los Angeles, Seattle, kind of in between, kind of mid-level, and Denver a little bit. I guess that falls into the middle bucket, but definitely New York City is the higher end of the spectrum for ADRs, right? So then again, you see the overall ADR versus the revenue per average room. So we see a nice breakdown here. So again, we see the high level. We see kind of like this trend, this kind of consistent, a little choppiness, a little bouncing around, right? But pretty steady. And again, it's really driven by the region, with New York City being the highest and probably Portland being the lowest, right? So here is another chart down here. I like these heat maps a lot, right? So the darker color indicates a higher revenue PAR, right? This is per average room of revenue, right? So pretty consistent. New York is expensive. Portland is a little bit cheaper. So the lighter color is cheaper. This is 74, PAR 74. Over here we have 160, 166, 145, and then 144. What else is kind of cheap? Nashville is a little bit cheaper. Denver is a little bit cheaper. LA kind of bounces a little bit in the springtime, early summer. LA is a little bit more expensive. Nashville is pretty consistent, and Seattle fairly consistent down here. Here's the 12-month rolling RevPAR. Okay, again, you can zoom in if you need to see the details for all these plots. That's what I love about Plotly. And then if you want to add or take something out, you can certainly do that. So here's New York City. If I want to get rid of that, I can see the others. And if I just want to focus in on these 3 cities, I've got that, right? So again, you can click on, click off. Here we have the revenue PAR overall. This is for New York City. ADR effect. So this is the average daily rate effect. Not much of an effect, pretty constant. Interaction over here, and then revenue PAR for the current year. This was the previous year. So pretty consistent for New York City. Again, ADR versus occupancy, weighted ADR. So again, you see this kind of flat, kind of consistent lines, a little bit bumpy, but it really doesn't vary too much based on the season or the date. Very little fluctuation, but not huge jumps up and down. And it really depends more the geographical region that you're operating in rather than the time of the year. So what kind of insights do we get from these charts? New York and LA are the top earners. Miami shows big seasonal spikes. Portland is the lowest and the flattest. Okay, and that is something you can communicate to your stakeholders, even to your staff, right? The people working at the hotel, the cleanup crew, the restaurant servers, and things like that, right? Because you're going to have to staff the hotel to cater to the guests that come and stay with you, right? And I actually have a couple videos on my channel that describe exactly how to do that, right? And how to optimize that part of the business too. So what else? Occupancy is relatively stable, usually 50 to 60%. ADRs fluctuate a little bit, and they kind of change by the month, but you don't see these big, choppy up and down swings, right? This is useful for pricing and revenue managers. We saw a couple heat maps, right? And NYC is consistently has the darkest cells. This is the highest revenue PAR, right? So we saw that over here, revenue PAR by month, and we saw another example of that over here as well, right? So darker is bigger, lighter is smaller. So we saw a couple examples of that. What else? Miami shows the strong early year RevPAR that could be due to spring break, right? We could do like a little bit more of a deeper dive and tease that out, and even look at a causal inference. So I do have a video on my channel about causal inferences and how to calculate those. So that might be an interesting next step if you want to do a deeper dive here. I didn't get into it, but I think that's okay. We are looking at basically hierarchies and doing time series forecasting. So that's very different from causal inference. I don't think that really belongs here. But if you wanted to level up and get this to the next step, that might be one way to go with it. So we saw occupancies, ADRs, revenue per available room, bookings, and then total revenue for each of these geographical regions. NYC has the highest total revenue. LA is close behind. Portland lags. That's totally fine. Probably just cheaper to do business there, and you charge less rent for the rooms, right? So that's just the way it is. That's totally fine. And this is basically a summary of the high level again for the investors, the stakeholders, board of directors, whoever needs to see the big 10,000 foot picture, but we also have the details too, right? And we can reconcile these two in between because we started out high level and low level and met up in between, right? So we married these two together to take care of anything that does not reconcile. So we have reconciliation here. We have good insights. We have good forecasting into the future. That's the time series part. And the hierarchy is looking at these different geographical regions and getting more, developing a better understanding of how these regions operate relative to themselves, but relative to the entire hotel chain that we're analyzing here. So that's it, guys. We are at just about 23 minutes right here. I'm going to wrap it up. I think I beat this horse to death. I think I covered everything that I need to cover. If you have some comments, put those in the comment section. Hopefully this is useful and helpful and informative, and just trying to drop some knowledge here and share my insights with you guys. So that's it. I will save this code and share that with you. I'll post this video a little bit later today, and I'll post all the source code so you have everything you need. You can copy and paste this into your own Jupyter environment and run the code right out of the box. I guarantee all this will run as long as you have all of the required libraries that you can see right here. There's only a couple of them. If you don't have that, go ahead and install that. It's just a pip install in Anaconda. And that's it, guys. I'm going to wrap it up. Thanks for your time today, and I will see you in the next one. Bye for now.